I would like to present paper 17.8, which deals with a bidirectional OLED microdisplay that combines a display and an image sensor functionality into a monolithic CMOS chip. And we demonstrate that with this demonstrator over here. So that is actually a see-through optics. So maybe you can see the display in your camera, and the display that actually provides the display image is over here, and this device also contains an image sensor at the same time. And the idea is that one can use these eyepiece and get a virtual image from the display, from the OLED microdisplay, and by the embedded image sensor, or at the same time the eye is being detected, the eye movement is being detected, and by that it yes, we should have a chance to see the eye over here on the screen, and at the same time I'm of course still looking on the virtual images. And the basic idea is to have virtual buttons in this virtual images from the display, and by fixing my eye onto such a virtual button, as it is shown for instance here on this poster, here I have such a virtual button. I fix my eye, my line of sight of the eye, maybe for half a second on this radio button, and this is being detected, and then an action will occur. Maybe the radio will switch on or switch off, or also the display can switch on or switch off. So this is the basic idea of that approach. We see several applications of that approach. One application could be in automotive, for instance, to provide mission critical information, for instance here in bad weather driver support. So let's assume we have a rainy windshield, and this system gives you information about the distance of the cars driving in front of you. But another application could be in mobile communication. For instance, let's assume you have a real view on your through your regular eyeglasses, and then a short message is being displayed, and if you if you fix your eye maybe again for half a second on the virtual delete button, then this message is being deleted. Also some other application in industry, in mobile maintenance or microsurgery, where the physician or the worker needs a hands-free or needs his hands for performing his actual work, and gets additional information on the screen, for instance of his eyeglasses or also of his operational microscope, and is able to control the content of the screen just via moving his eyes. And also of course some security applications could be thought of, for instance a firefighter who is in disaster management, who gets additional information on the scene on his screen and is able to interact with this information just via his eyes, and still has his hands free to operate in his environment. Okay, so the basic technology that is behind that approach is a so-called bidirectional OLED microdisplay. So we have a CMOS backplane layer, and on top of that we deposit the OLED, and just by patterning the CMOS top metal we are able to achieve micron size individual OLED sub-pixels, maybe in the size of, let's say, 5 by 5 micron, and by having a lot of those tiny micropixels we achieve a QVGA, in that case resolution of the display, and side by side with the OLED display pixels we still have the image sensor pixels, and these image sensor pixels are in our case 160 by 120 resolution, and these are combined in a matrix where we have the image sensor intersected together with the OLED microdisplay matrix, and both can be operated completely independently. So we have a simultaneous as well as simultaneous mode where we can detect and display an image at the same time. For this head-mounted display application, as I have shown over here, we have a certain see-through optics as shown over here, and these see-through optics has a certain specifics. So here this is a bidirectional OLED microdisplay device. The display imaged is or the display imaging passes via the green lines towards the background of the eye, whereas the image sensor looks onto the eye foreground, especially the pupil, and along the red ray passes the eye image is being projected onto the image sensor. Here that gives you an imagination of the setup of the embedded display and image sensor matrix. So this would be a single display pixel, and inside each of these display pixels, these holes are actually the image sensor pixels. So by that I have the co-functioning of the display as well as image sensor functionality.